Everybody, welcome back. We'll be talking about data manipulation today. So if you go to the website, johnmichele.com/intro to R, you should be able to go to day 4 and open up the HTML slides for data manipulation. All right, let's get started. So in this module, we're going to show you how to reshape data from wide to long. Also, sometimes in some settings, people have called it fat to tall, but those terms have generally gone by the wayside. But if that's the way you think about it, or that's what you were taught, that's what we'll be kind of going through. And then reshaping the data back from long to wide, merging data and performing operations by a grouping variable, which we've already covered in some other instances, but we're going to refresh some of those things. And I will define kind of what I mean by wide and long. We will show everything in the dplyr or tidyr package. If you go to the ends of these slides, some of the other base R implementations will also be discussed. So what is wide or long data? So if you click the link in the slides, it has some discussions about that. But many people believe, especially in medicine, that wide data has, for example, a person or an identifier, a unique identifier. It has multiple visits along the columns or multiple observations along the columns, such as visit 1, visit 2, visit 3. And they're usually consistently named, things like that, except for maybe sometimes it's like baseline visit, visit 1, visit 2, visit 3, and then like last visit. So many people think the data wide to look like something like this, where we have ID 1 and 2, and we have visit 1, visit 2, visit 3. And for example, visit ID number 2 either is missing visit 3 or it hasn't gotten to that follow-up date yet. Alternatively, the way many people think of long data is multiple rows per, let's call it, observation. So the unique identifier for each row is the ID visit combination, not just the ID itself. And so this same exact data is represented this way, and we see we have dropped visit 3, for example. So instead of 1 row per identifier, it's multiple rows, but the ID and visit combination actually correspond to unique rows. And we see the ID repeated, and we see for ID number 2, there is no visit 3 because that value is missing. So more accurately, I would say that data is wide or long with respect to certain variables. For example, if you have multiple visits of people and they get their blood pressure measured 3 times at each visit, and let's say there's 6 visits, right? You could have the data where each ID was multiple rows, where it was ID 1, 1, 1, 1, 1, visit 1, 2, 3, 4, 5, 6. But then you could have columns, blood pressure 1, blood pressure 2, blood pressure 3. So the data would be long with respect to visit, but still wide with respect to blood pressure measurements. So just whenever you hear wide or long, I would always try to caution you and saying that what is it wide or long with respect to in the data set. So here we will be talking about the circulator data set, because it's a great longitudinal data set to show you how to reshape some things, and it's actually given to us in a way where I believe some reshaping is in order. So we are going to read an object using read_CSV. We're going to be reading directly from the internet, so we can just pass in the URL into read_CSV. Again, I'm pasting the strings together because I didn't want to have this URL run really, really, really long on the page, and it's just an easier way to break it up and, see all the code in one spot. But you could have just pasted the entire long URL. So we're going to call this object circ, and we are going to look at the circulator data, and this is the output of what's read in. We're looking at the first 2 rows. So there is a variable called day. There's a variable called date. There are variables for orange boardings, orange A lighting. So boardings are people getting on, A lightings are getting off, and average is the average between the two. Again, these circulators are buses that run throughout the city. So there's the orange line, the purple line, the green line, and actually the banner line. And then there's another variable that's just the daily ridership of all the lines across the city. So we should see here that day is Monday, Tuesday, Wednesday, Thursday, Friday. So that's obviously going to be repeated over and over again, but the date should be unique. So if we actually look at the class of the date, it's a character. So we are going to first change that date into a proper date, so that sorting and all the other differences and anything we want to do with dates that's appropriate works. So again, we're going to be using the lubridate package. The lubridate package is the, I would say, premier package for working with dates. As its name says, like lubricate, lubridate, it making things work smoother with respect to working with dates. So sum is.na circ dates. We're saying is.na, are any of these values, or is.na will convert each individual element into a true or false. If it is an NA, it'll come up true, and we take the sum of them. That'll give us the number of records in a data set that are missing. So we see here it's 0, so we're sure that there are no missing values in this. And remember, read underscore CSV will take empty strings and turn them into NA. So it's not like there are some empty quotes just kind of floating around there. Those would be converted to NA, and we can see that here as well. We can say circ $date equals equals. Remember, this is a logical operator testing whether this thing is equal to an empty quote. So again, all the values of this data set have a date, but it is still a character, and we are going to convert it to a proper date. Now, we could have used functions like any. Are any of these equal to this, any equal to that, and that would have given us a true or false, but some would have been a little bit more generic because it'll give us, the number of cases if any of them show up. So we're going to mutate circ, and we could have done use the pipe to pipe in circ in the mutate data set. And we are going to say date equals MDY date. So again, the way this data was encoded is month, day, year. So that's why we're using explicitly MDY, because that is the command from lubridate that will convert a character date into a proper date. And we want to just replace that date column. We don't want to create another column. That's why we're doing reassignment here in mutate. And then we want everything to actually stick on the circulator data set. So again, you have to reassign the complete output of mutate to a data set. And in this case, it's the same exact data set, so it's going to overwrite it. So lubridate will give you some messages if there were any conversion failures. And we are noting here as well that we're testing again, did any of the dates become NA or become missing? And the answer is no. So anytime you're doing data conversion, turning characters to numbers or anything like that, I think it's a good check to make sure if you have any missing values before, you should have them after if that's what your intent is. And if you didn't have any NAs before, none of them creeped up by your conversion. So we should see here that if we look at the first three elements of date, the first three dates of this data set are, January 11th, 2010, January 12th, January 13th from 2010. And it looks like it's in quotes, but again, if we look at the class of this, it is a proper date. It is not a character. Okay. So talking about things in base R, the reshape command exists in R. Do not use it. It is confusing. I have never been able to, in one fell swoop, just use the reshape command once and be happy with the result, or actually not get it fail. We are not going to use that. What we are going to use is tidyr. So tidyr has 4 functions that we will be talking about. 2 of them we've already covered. Separate and unite allow you to do string manipulations to split strings into multiple columns with separate and put them back together with unite. And we've also talked about pasting and things like that. The 2 new ones we'll introduce in this lecture are gather or spread. Gather takes up multiple columns and turns them into variables. Also, you can think of it as converting data from wide to long. And then spread takes a variable and turns it into multiple columns, which you can also think of as turning long to wide. So there are 2 other functions that have been implemented in tidyr that we will not cover that I will highly suggest you look into, especially if you are used to the word pivot. So there are functions pivot longer, pivot wider, and they're a little bit more complex, but they are newer than the other gather and spread. So we will at least show you these things, but we're not going to actually go into them in detail because they can do much more powerful things and a bit more complex, but many times all you want to do is gather a few columns or gather a few rows or spread out a few rows actually. So again, the gather function from tidyr puts columns into rows. So the like all the dplyr functions, again in tidyr, the first element is always the data. So the 2 arguments that are really important here are key and variable. So key is saying, what do you want? So you've in this case, we had 3 columns, or we had columns that we wanted to turn into rows. So they were the orange boardings, the orange A lightings, the orange average, right? So the purple boardings, A lightings, averages, over and over again, all those things for all the lines. We want to turn those to be rows because we want to have, at the end of the day, a column for boardings, a column for getting off, a column for the average of the two, but we'll have a variable that indicates which line that is for the day. So the things you pass into it are the key. What do you want to call the new variable that represented the column names from before? It's like, I took data from this column. I took data from that column. What new variable do you want to create corresponds to the previous column names? And then you actually have to take the individual data, the data that doesn't represent the column names, or the data that represents the values themselves. And so that is the value argument of gather. So again, there are 2 things you're really doing. You're taking columns and you're turning them into rows. So you got to put the number somewhere, and that's the value column. But then you have to say which variable did this come from? And that is the key variable. Okay. And then the last argument, what you give gather, is this. You give it which columns to gather up. So gather is very much like select. You can use the select helpers, and you can use the same syntax that you've been using previously to select columns. So anything you put in here, you'll say, I want to either gather everything but these columns, or you can say, I want to gather specifically these sets of columns. So here we're going the first way. We're saying, I want to gather everything except for the day column, and the daily column, because those are things that aren't really repeated in the way the other data is. So here we see what the output is, and we call the output long. So there's a day, which is still day of the week, date and daily. None of those are changed at all. But for example, where we had, let me go back, orange boardings, orange A lightings, orange average, and things like that, those have all been converted into individual rows where the numbers have been filled in. So there are other options for gather. I would highly recommend looking at the documentation for that, but that's one way to do it. Similarly, instead of saying everything but those columns, we can be more explicit. Again, everything from here on up, or here on to the left, is exactly the same, except now we are saying explicitly, I want to gather up the columns that start with orange, start with purple, start with green, start with banner. So again, there are multiple ways to do this. We are using these modifier, or these select helpers, in the same way we're using them with select. So it's saying, I want to gather all the columns that meet this criteria. And again, we get the same thing out. Okay, so 2 different ways to do the same thing. And just doing some countings and just showing you all the variables that we actually did gather up: banner, green, orange, and purple, A lightings, average, and boardings. Okay, so again, we're using the count function from dplyr just to show that, yep, these are the things that actually got reshaped. So we're going to pause here and we're going to do some reshaping in the lab. So I'll pause your lecture and then maybe jump out to that, which should be on the website. So if you go to the website, again, it should be next to manipulating data. You should be able to click the lab, and that should be able to open up in your RStudio. Okay. Coming back, we've talked about stringr a bit. So we talked about str functions from the stringr package. Again, stringr is in the tidyverse. So if you load up the tidyverse, this will just be in there. And what we're going to do is we're going to put some separators in the variable, the column name var, which I use as a shorthand for variable. That's why I chose to do this. And what we're doing is actually taking the data set and pumping it into this mutate function. But within the mutate function, we're saying var, which is already there. We're going to replace it with the variable var. And now we're using the pipe again. We're using the pipe inside mutate this time. So it's a little bit different than maybe what we've done in the past. We're taking this thing from before, these vars, and we're saying anytime you see the word board, replace it with underscore board. Anytime you see a light, replace it with underscore light, and the same thing with average. So again, if we do this counting, we see we have effectively put underscores between all these. So why is this important? Because we're now going to separate those columns. So again, using the tidyr function, we are going to separate that newly underscored function, or underscore variable var, into a column for line, which line, the orange, the purple, the green, or the banner, and then the column for type saying, what does this number represent? People getting on, people getting off, and we're explicitly saying that the separator is underscore, otherwise, again, separate is going to guess. So this is the output, and again, by default, it removes the original variable in there. If you don't want that to happen, say remove equals false, but it took this variable, split it into line, into type, and if we do the unique elements of line, we see it's orange, purple, green, and banner, and the types of values we have now are boardings, a lightings, and average. Okay, so now we can reshape this data where we have a column for orange, a column for purple, a column for green, a column for banner, or what we could do is have a column for boardings, a lightings, and averages. So we are going to end up doing the second one. Alternatively, again, if we had the opposite problem, we could use the unite function where we actually pasted everything together, but we've already talked about that in the past, and you can also use paste or paste zero in the string manipulation. So, okay, we're going to pause here, and we're going to go to the second part of the lab. Okay, coming back, what we are going to do is here, all we're doing is creating a data set called wide and saying, if there are any missing dates, I want to get rid of that. So we've already done all the checking for this. So this is kind of just redundant. But the real important thing here is we are taking that data set long and running spread on it. So spread takes two arguments as well, similar to gather. Gather really takes 3 or 4, the data set, the variable you want to create for the columns, the variable you want to create for the values, and then what do you want to gather up. Alternatively, spread obviously takes in the data, but it says, what do you want to actually spread out? So I want to spread out the type column, and the types were a lightings, average, and boardings. And what do you actually want to fill in the data? So again, what is the value you want to put in these newly created columns? So type was a column that was previously in our data set. Now we're spreading out, and we're filling it in with number. And you see after that, we now have a day of the week, the date, the daily ridership, the banner, green, orange, and purple lines separated out. And now we have an individual column for a lightings and average. So let's look at this as opposed to this. So boardings, a lightings, and average were all lumped together, and we had numbers for that. And now we're spreading this out. So now we can drop things. For example, if you're missing average, or you're missing board, or you're missing a lightings using filter, you can do a filter where if you're missing any of these or all of these, you can drop them. But that is the key concepts of spreading and gathering. Gathering, you say, what is the new variable you're creating? That represents column names. What is the new variable you're creating? That represents the data. And then spread, you're saying, what column of like generally characters or categorical variables do you want to spread out and make them columns now? And then what do you want to fill that in? So they're kind of complementary procedures. So, okay, we're going to pause here, and we're going to move on to lab part 3. So we are going to be talking about merging or joining data. So those who come from a database background, joins are like life in the database world. So I'm going to show you 2 very simple. This is one of the instances we're going to use some toy data sets because it's to demonstrate a point on how joins work. So here we're making a baseline tibble where IDs are 1 to 10. We're just giving them some random ages. So ID represents in this setting like an individual, and we called it base because in many settings in health, you have a baseline visit and some demographics or information you take at baseline that probably doesn't change. So here we had IDs 1 to 10, and we have their ages. So visits represents like follow-up visits, which is pretty common in healthcare data, and it has identifiers 1 to 8. Okay, so that's what we're doing. We're saying repeat 1 to 8 3 times. And we're also adding this new ID 11. So for example, let's say 10 people came to the follow-up visit for the study. And then for the for the baseline visit, and for the follow-up visits, people are coming in. IDs 1 through 8 came in, had their follow-up visit, and number 11 said, hey, I missed the baseline visit, but I'm here for my follow-up. And so number 11 had some sort of outcome at their 3rd visit. But it missed everything else, for example. So these are just 2 basic data sets that will be showing how different joins work. So merging or joining the data sets together is usually on key variables, some sort of identifier, things that uniquely identify rows of the data. So if you do question mark join, you'll see all the different types of join in dplyr. There is a data wrangling cheat sheet which talks about these as well. So usually, or in almost cases, what we're doing is joining two individual data sets. You can do joining two individual data sets, join that result with a third one, join that result with a fourth one, and so on and so forth. But at any given join, we're just joining two things. So in these settings, we'll call it X and Y. Those are the arguments of the join functions. So if we say inner join of X and Y, right, what it will do, if we don't give it an identifier, what do you want to join it by? It's going to look at the columns of X and the columns of Y and say, hey, what are the columns you guys both share? I'm going to assume that's the one you want to join on, which is maybe what you want to do, maybe not what you want to do. So we will show you how to specify the by argument. But what it does is whatever you're trying to join on, it takes the rows of X and the rows of Y, and it gives you only the ones where they merge, only the ones where they match. So that's an inner join. So you can think of it as kind of like the inner product of the two things. A full join is all the rows of Y, all the rows of X are kept. It doesn't matter if this row didn't match up with anything in Y, and it doesn't matter if this row of Y didn't match with anything with the rows of X. Doesn't matter. Every one of them is kept. So left and right join are almost identical in what they do. It just depends on what is what you think of kind of the master data set. So those who use Stata like master and using X is the master, Y is the using data set. So X is the data set we'll be joining with Y. So if we're using a left join, X, all the rows of X are kept no matter what. It doesn't matter if it joined with Y or not, all the rows of X are joined. Okay, so that's what a left join is. So left, X is the one you really care about keeping all the rows. A right join, alternatively, Y is keeping all the rows. All the rows of Y are kept even with respect to X. If none of them merge with these things of Y, then it's still going to be there. So these are pretty complementary. If you switch the arguments around, they're almost exactly the same join. There are some slight differences in the sense like how the output is ordered, but the data that results are the exact same thing. If you did a left join with a data set and a new data set, and then you did a right join but switched the arguments again, they're the exact same procedure. Anti-join, again, is a little bit, it matters which one you choose for X or Y. So this says all the rows of X are kept that are not in Y. Okay, so the anti-join. So if you say like, hey, which ones, I really care about X, but which ones end up not joining with Y, you can use an anti-join to find those. So here, we're going to go through a couple joins with that toy data set and show you what comes out. So IJ is the inner join between baseline visits. And again, we didn't specify anything. It says, hey, I found an ID column in base. I found an ID column in visits. I'm going to join by that. Now note, again, R is very picky. It's case sensitive. If it's capital I in here and lowercase I in here, it's not going to join by ID. So we see we have 24 records out, and we're looking at the tail. So we've showed head many, many times in these lectures. Tail shows the bottom 6 rows by default of a data frame. Head shows the top, tail shows the bottom. So we see, we remember that in visits, the rows, an ID 11 came on board. And also you should note in visits, IDs 9 and 10 never showed up. So they never had any data. So all those are dropped from this. Only the IDs 1 through 8 that had baseline data and had follow-up visit data are now in this resulting data set. Alternatively, we said, hey, I want to keep everybody who had a baseline visit, but these follow-up visits, if you had them, that's great. If not, then I'm going to drop you out. So that visit, that ID number 11 had follow-up data, but it had no baseline data. So again, we see there's different numbers of rows here because IDs 9 and 10 had baseline visits, but they're missing outcomes now because they had no follow-up visit data. Okay. And left join, it matters the order that you do it because again, base, we're keeping everything in the base data set, but not in the visits data set. So some people don't really like joins compared to Stata or SAS. So like, I actually want to know, how many, you don't have this underscore merge variable, things like that. So there is a package called TybeeLog, which can show you the log outputs from dplyr, right? So it's a relatively new package, but if you load it up and you do the left join of base and visits, it'll give you the same table out, but it'll give you some more verbose information to say the rows only in X, there are 2 rows only in Y. You see this one, the match rows were 24 and the one is 26. So this parentheses about Y means those rows were dropped. Okay. So that's what the parentheses there says. Hey, you had somebody in visits, again, that ID number 11 that wasn't in baseline, and we dropped them out. And then we're also going to keep these 2 rows that are only in X. So now that we've turned on the tidy logs, we'll be seeing that for mostly all the rest of the joins. And again, if we say right join, base, and visits, we kept the arguments the same. So now visits is kind of the master that we're going off of. And we see now we drop those 2 rows, IDs 9 and 10, that didn't have any follow-up data, but now we include ID number 11, which has outcome data, but never had any follow-up, or sorry, had never had any baseline. Okay. So different types of joins depending on what you want to do. Again, all this, the only thing that this slide is showing you is what I was saying before. If you switched up the order and say visits was X and base was Y, but you did a right join, that should equal identically the left join that you did before after some rearranging, right? So the arrangement of the rows and the columns might not be exact, but after you reorder things, they are. So pretty much this was just demonstrating the thing I've been saying. Now, a full join says, I don't care if you're in X, I don't care if you're in Y, I don't care if you're in both, you are coming in this data set. So if we look at the tail of FJ, which is the output of the full join, we see records 9, 10, and 11 are in there because all the records 1 through 8 are already still going to be in there, but records 9 and 10 were in baseline, but had no follow-up. Record 11 had follow-up, but no baseline, but they're all included in a full join. So sometimes people ask, what does the duplicated function do? Because is that used for merging? It's not really. What it does is when it passes in a vector and it gives you true for if that element has been duplicated, and it becomes true on the first instance in every instance after that. So when I'm showing you here, 1:5 is just giving me 1, 2, 3, 4, 5. And then I'm appending 1 to this. We say duplicated, none of them are duplicated. But when I say duplicated 1 through 5, it says false, 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 true, because it found a second one. Note here that this one did not come up because it wasn't duplicated yet. So it's a little bit unintuitive to some people because that's not the behavior they'd expect. But sometimes that can be useful to find duplicates for duplicate identifiers and things like that. There's also a function called distinct, which is very similar to unique, but you pass unique or distinct onto a data frame. If rows are identical, if 2 rows are absolutely identical, then it will drop one of them. And again, it doesn't matter which one they drop because they're identical. Duplicated is one function out there. There is, because it gives a logical, you can then combine any with duplicated to see if any of them are duplicated or all are duplicated, things like that. So we're going to move on to part 4 of the lab. We're going to pause here, and then we're going to talk a little bit more about pivots. Okay, again, as of 2019, pivot longer and pivot wider are new functions, which has a good article here on how to use them. They're very powerful. They're a little bit more complicated than spread and gather, and we found that most people for spread and gather, just starting out, are good enough. But if you are needing to do a lot of reshaping, reshape a lot of different columns, like that instance I said where you have 3 visits, 3 cuff measurements for blood pressure at each visit, this might be the function for you. Okay, so that is data manipulation. We've talked about how to gather columns up, turn them into rows, take rows and spread them out into columns and fill it in with data. We've talked about how to join 2 data sets together and what happens when you do a full join, inner join, left join, right join. We haven't really discussed what an anti-join is, but pretty much we described it in the lecture. And then lastly, we talked about the TybeeLog package, which gives you some nice output to say, hey, like what is going on with this join. So we talked about how the merge function exists, but we are not going to use it. The reshape function also exists in R. We're not going to use that either in base R, let me say. So let me say join. So again, if we look at the arguments of join, again, by default, by, if we say is null, it is going to try to look for all the intersections of different columns. So let's take two data sets here. We're going to load up our dplyr data set, but let's just load up all the tidyverse. That should be fine. And I'll show you very briefly two examples. So if I say band members, so they join by name. If I said something else, so I can just say, this is what I want to join on. So if I say name band for the band members and band instruments. Now, what happens if you have a column that you don't want to join on, but they're the same name? So let's say band members, let's say mutate X equals 5, band members. So I'm just going to make that stick. So I'm going to reassign it and band instruments. Oops, that's band instruments 2. Mutate X equals 5, X equals 2, something like that. So if we do inner join on that, well, let's do it first where we don't say what we want to join by, and it's going to say, I'm going to try to join on X and name. And now we know that in the band members, X equals 5 for everybody. In the band instruments, X equals 2 for everybody. So it tries to join the two, tries to do an inner join, only give the ones where they match up, and it fails because none of them actually line up. If we say full join, it's going to try to, again, default, try to join on name and X. But that's not what we want either. Usually you want to specify what you want to join on. So again, you can give it a vector of things. That's the equivalent to doing this. It's exactly the same way. But we know that name is actually the thing we want to be merging on. So what will happen here, because both of them have the column X. So if you look on the arguments here, let me go here. Let me go back to the joins. There is an additional argument called suffix that says if something doesn't match up, or let's say in this case you had X in one, X in another, but you're not merging on those, what do you want to call those new variables out so you know distinctly what they were? If they're both called X, you can't tell which one's which. So if I say suffix member band or instrument. So now the X column that was from the member is now called X member. If otherwise it's called instrument. And if you are gonna, it is gonna result in something like this. It's good to actually define the suffix as well, because many times you're like, which one was X, which one was Y, and sometimes these aren't as informative. So if you do have something where, let's see, so band members. Band instruments 2. So we see this one has name band X. This is artist plays X. You're like, oh no. Like if I do left join of these or inner join of these two of band members, it's going to say you have no common variables. You have to like tell it what to put in there. So if I say name, it's going to say, hey, I don't have any name column in band instruments 2. I would highly suggest that you rename the column yourself. I think it's, oops. So if we go back to the joins, lastly, if we look in here, you should be able to say by. For example, you can put something like this, where if band members, it's called name in X, you can say that is mapped to the artist column in the second one. So you can actually do this on the fly, but again, I would highly recommend renaming the columns here so they do match up so when you merge them. But dplyr does give you a way to map one variable to another, but you have to pass in a named vector. So again, this is a vector. We're doing the collect function, and I'm saying this is what it is in X, and this is what it is in Y, and that's the ones I want to merge together. So that is joins in a nutshell. And if we look, band members, band instruments, right, we do see that there is some disjointness here. So lastly, I'll just show you an anti-join. And this, again, the order matters here. So I'm saying band members, band instruments. So I'm saying this is a record that is in band members, but not band instruments. And I can do the same thing. And I'm just going to use band instruments because they are the same name. I don't have to do any of this mapping. So let's do by equals name. So this represents someone in the band instruments data set, but not in the band members. So again, let's compare that one with this one. So again, Mick is in band members, but not band instruments, and Keith is in band instruments, but not band members. So that is an example of an anti-join. But that is the long and short of it, and the documentation is very helpful in these, and it's quite good. Thanks.